Good evening, sir. I'm Midshipman Tapulayan. In this video, I will discuss about the stability information using various stability diagrams, trim tables, and stress tables used on board ships. Stability diagram. Stability diagram is a graphical presentation used to analyze the stability of a system, whether it is a structure undergoing model analysis, a dynamic system in a mechanical vibrations, a flow regime in the magneto-hydrodynamic or MDH, or a geographical system. Ship stability diagram shows a center of gravity, center of the buoyancy with the ships upright and held over one side. When we talk about ship stability, according to Marine Insight, there are three types of ship stability conditions. Number one is stable, number two, neutral, number three, unstable. Ship is stable when the center of the gravity or G is located below the metacenter. This means that if the ships heel over, the force of buoyancy will act through the center of the buoyancy, creating a moment that will return the ships to an upright position. A ship is in neutral stability on a ship's diagram if it is presented by the ship's center of gravity or G and the metacenter coinciding, meaning the metacenter height is 0. In the state, if the ship is heeled over to a small angle, it will tend to remain at the angle of heel until another external force acts upon it. Essentially, there is no to either a ship's or it may heel over further. Ship is unstable if the center of the gravity is above the metacenter, resulting a negative GM. This means that the ships will not return to an upright position after being heeled, and will instead heel to one side. Trim table in ship stability. Trim refers to the difference between the forward and aft draft, or the depth of a ship's hull underwater. Trim tables used to determine the amount of ballast or fuel lie loaded or discharged to maintain the design trim. This table helps to calculate the effects of changes in weight distribution on ship's trim and ensure the ship's floats level at the designated trim angles. Different kind of trims. Number one is positive trim. If the draft up is greater than the draft forward, the ship is said to be trimmed by the sterns. Number two is negative trim. If the draft forward is greater than the draft aft, the ship is to be trimmed by the head or trimmed by head. Number three, zero trim. If the draft forward and the aft are equal, the ship is said to be or uneven keel or trim even. How trim table are used? The purpose of trim table is to determine the amount of weight or fuel to be loaded or discharged to achieve desired trim. In calculations, the officer determined the hundreds of tons to be loaded in each trim tanks. In adjusting draft, the resulting figures are added or subtracted to the forward and after drafts to calculate the new trims. Stress table in ship stability. It is a hydrostatic table contains data related to the ship's buoyancy, displacement, and the other parameters at different draft and loading conditions. These tables are used to calculate the ship's stability characteristics such as metacentric height, right level or GZ, and the other stable parameters. The information in this table is crucial for determining the ship's stability in both intact and damaged conditions, as well as for assessing the effects of various loading scenarios. The importance of understanding stability information using various stability diagrams, trim tables, and stress tables used on board ships. Number one is prevention of capsizing. The most critical aspect is prevent capsizing. Stability diagrams, trim tables, and stress table helps determine the ship's stability under the various loading conditions, including cargo fuel and ballast water. By understanding the ship's response to different loads and environmental factors such as wind and waves, a crew can make informed decisions to avoid exceeding safe limits, and prevent capsizing. Number two is for safe cargo handling. These tools are essential for loading and unloading cargo safely. Incorrect cargo distribution can significantly affect the stability. Stability diagrams and trim tables guide the crew in determining the safe place of cargo to maintain the stability within acceptable limits. Number three is emergency situations. In emergency situations such as flooding or damage stability, data is vital for assessing the ship's conditions and making appropriate damage control decisions. This information guides the crew in determining the best course of actions to minimize the risk of capsizing and maintain structural integrity of vessels. Number four is compliance with regulations. International maritime regulations require ships to carry and use stability informations. Adherence to these regulations is mandatory for safe operation and compliance with international standards. Number five is efficient operations. Optimize loading and ballasting guides by the stability informations improve efficiency. By understanding the ship's stability characteristics, the crew can maximize cargo capacity while maintaining safety margins. In conclusion, the proper use of stability informations contribute for ensuring the safety and efficient operations of ships. Training and expertise, interpretation, and applying this data are essential for all crews members involved in cargo handling and ships management. And that's all, sir.